It's early autumn, and what better place to be back at school than Villanova University? We're here to view a wetland site that's used for research and demonstration. But more specifically, we're going to take a look at the Sediment Forebay. Now, this is a simple but very important part of the wetlands. The forebay is the structure that catches sediment from runoff before it enters the wetlands. The sediment is stored in the forebay for removal. Our host today is Dr. Robert Traver, who is an associate professor of civil and environmental engineering here at Villanova. Now, the sediment forebay is just a part of your research, so tell me a little bit about the whole site.
Well, what you see here is what we call a retrofitted stormwater wetland. It's one of the best management practices. We are trying to build a whole group of best management practices placed where they should be as part of some of the Pennsylvania's programs and research in these areas.
Tell me, what exactly is a sediment forebay?
Well, a sediment forebay is usually part of a larger device. Currently, we call them best management practices, for an example, and I know you've had some of your other videos on some of these devices. But the basic premise here is to capture sediment before it gets into our wetlands, which we've built right downstream of the site. The whole idea is it's a lot cheaper and a lot easier to go through every couple of years and scoop out the muck out of this little pond than it is to go through and destroy the plants that we planted downstream.
And tell me a little bit about how this was built and who built it.
Well, we built it as part of a 319 non-point source pollution grant through Pennsylvania that's applied by EPA. And this whole site was originally a mowed detention pond that had an underground pipe trying to get the low flows through the system quickly, which is no longer a good design practice. So what we did to build this site was we actually built this first, and we dug a big hole in the ground, and we put in some pumps to dewater it while we were building it. It's about 40 by 40 and about 4 foot deep, and that's sized based upon the amount of impervious surface in the watershed. We then poured a concrete pad on the bottom, and the whole reason for having the concrete pad is to support the maintenance, so we can get a piece of equipment down here and clean it out without it sinking into the muck. And then we built these gabions. These gabions are designed to be the outlet structure. You notice it's kind of stepped down here to let different levels of flow through, but they're just rocks in a basket. So we also piled dirt behind them to make them a little more waterproof. And then when we were done with all that, we just continued the dirt and blocked off the rest of the stormwater wetlands, forcing all water coming from campus, coming from our big parking lots up there, to make sure it goes through this structure. As part of the design process, you notice that during a hurricane, this might be several feet higher. So during large floods, we don't necessarily want the water to have to go through here, because we'd worry about putting the muck back into the stormwater wetland. So instead, the berm is fairly low, so in big storms, it just bounces over it.
So tell me, why would somebody put this in?
We found that historically, we've always designed for detention ponds to control hurricanes and big thunderstorms. The problem we're learning is the smaller storms have a lot more to do with the pollutant loads to the rivers and to the formation of the rivers. If there's more water, the rivers will move and they'll erode away banks, and then all of a sudden all your culverts are too small and people get flooded, which has been happening a lot around this area. This type of a site does treat non-point source pollution, and this is 40% paved areas above us. So the idea here is, and saw some frogs jumping in here as we came down, we've improved the quality of the water coming through here. In a site that was once designed only for hurricanes, now we're taking care of all the other storms too, and hopefully improving the water quality that leaves Villanova and goes into the headwaters of Mill Creek, which is right down across the road here. I think you're going to be seeing a lot of these in every little development. And the reason is that when you build the stormwater wetlands, you want to make sure they last. You don't want to go in there and mess around with those plants. This gives you a convenient place to collect the sediments that have collected, put them up as either topsoil or spread them out on your grass, and let it dry. If you don't do this, this is actually designed to actually save you money in the long run. So you don't have to go and work with the other parts of the project that are not so easy to replace or to maintain.
You could plant trees and shrubs to camouflage the forebay, and this can have multiple benefits. Not only will it look more natural, but the shade will cool the pond and decrease warming effects, and the dropping leaves will help feed water life. What do people want to know when they come and visit the site?
Well, it's funny. One of the biggest questions I get, are you creating a place for mosquitoes to breed? And the funny thing is, I've been out here working on this site for about a year and a half. I've probably had 200 or 300 visitors here. I've had grad students out here on a daily basis, and after all the plants grow, I've never had a single mosquito bite or somebody even being buzzed by a mosquito. We get dragonflies and birds and frogs and all those little critters chomp them up. So don't really have a bug problem at all.
Kind of takes care of itself.
Yes, it's a feeding ground, I guess. So I don't think they have much of a lifespan here.
That's it for class today. I know I learned something, and what a classroom to be in. Thanks for listening as we bring you more information on best management practices and ways to reduce the impact of stormwater pollutants in our waterways. And be sure to catch the rest of our series.